Welcome to MV Tutors. I'm your tutor, Fikakahle Manana, and today we're doing geometric sequence and series. This is a tutorial lesson, so let's get right into it. First of all, as you can see from the title, I have geometric sequence and series. Yes, it is there is a difference between the two. Okay, so here's the difference. If you look at this example over here, okay, we can see that this is a geometric sequence, but I will have you know that this is a geometric series. The difference between the two is just that with the sequence, it's separated with commas or semicolons, but with the series, you are adding up the numbers. Okay, so just remember that in the back of your mind. Now, I like to start a tutorial lesson with a vision, okay, what we are working towards before we actually start the lesson. So this is the vision. This is what we are working towards. This is from a past exam paper. We will be answering this question at the end after the lesson, the tutorial. You are given a sequence. They just want you to determine the nth term of the sequence if the sequence is equals to that number, and then they tell you to calculate this series. Now they don't give you up to what term you must calculate it on, but there is a way you would know how to calculate that. We will cover this in this tutorial. And then also I like to also present before you a practical presentation of where we would use this geometric series, or where we would use this lesson where it's applicable. Now here is a question. Okay, now this question is very, as you can see, it's in words, meaning it's a practical thing, that's a practical calculation you might have to do. It says Temba is planning a bicycle trip from Cape Town to Pretoria. The total distance covered during the trip is 1,500 kilometers. He plans to travel 100 kilometers on the first day. For every following day, he plans to cover 94% of the distance he covered the previous day. Now, first question, what distance will he cover on day 3 of the trip? Okay, on what day of the trip will Temba pass the halfway point? And then Temba must cover a certain percentage of the previous day's distance to ensure that he will eventually reach Pretoria. Calculate all possible values of this percentage. Now, that's the vision as well. We will answer this question. So if you don't know how to tackle any of these questions, if you don't know how to do any of these questions, then stick around and we'll get them. But first things first, we need to start with the theory. Break it down into small, understandable pieces so that we can answer these questions. All right, now let's get right into it. Now, I've already told you the difference between a sequence and a series. Okay, so let's talk about the geometric sequence, because there is really different kinds of series. Okay, but the one we're talking about today is the geometric one. Okay, so what makes it a geometric one? Now, this is a geometric series. It's given by this. If you have such let me just add one more so that you can see the trend. Okay, so this is a geometric series where A, as you can see, is the first term. Okay, first term, and then R, now this is where it gets interesting. This is where it really gets interesting, because R stands for ratio. Okay, but it's the common one. It's the common ratio, the ratio that is common between these. Now this ratio is given by, if you take the second term and divide it by the first term, it should give you the same number as if you take the third term and divide it by the second term. Okay, let's just and then that defines R. Okay, and then we have what we call Tn. Okay, Tn is just the term position. Okay, so Tn is a term position, and Tn general formula is given in a general formula, and its general formula is A times R, okay, and then n minus 1 is an exponent of R. Okay, or as I prefer putting it, I open the bracket, put R in there, close the bracket, and an exponent of n minus 1. Same thing. Let's just do a quick example. Say consider this number. Consider this sequence. Consider you're given a sequence of 10, 20, 40. First of all, we said A, and then we are asked to calculate the formula for any term. First of all, so we need A and then we need R. So for A, we've already defined it as the first term. R, we've already defined it that it should be term 2. So that's term 1, that's term 2, and that's term 3. Right, so term 2 divided by term 1. That gives us term 2 is 20 divided by 10. Okay, so 20 divided by 10 is 2. Now let's do the other one. Let me put a separation line there. This one, term 3 divided by term 2. If it gives us 2, then that concludes the common ratio. Term 3 is 40, and then term 2 is 20. 40 divided by 20 is 2. So, okay, it's confirmed. You can do it with just one of these. It doesn't matter which one you choose. I just did it in the interest of confirming that it really is 2. Okay, now that you have these two, you are ready to write your formula, your general formula, which is, as you can see, I prefer it in this method. Let me just say A R n minus 1. Okay, which in this case, A, we've solved it to be 10. And then R, we've solved it to be 2 to the power n minus 1. That's just it. That's it. There's nothing more than that. Now, if they ask you to calculate a certain term, say for example, I generally like to calculate term 3 just to confirm if really our formula is right. Remember, it's 10 2 to the power n. Instead of n, remember here we had n, now n is 3 minus 1. Okay, we already know term 3 is 40, but I just want to confirm that it is 40. Okay, so we'll have eventually 10, 2 to the power 3 minus 1 is 2, which is equals to 10. 2 to the power 2 is 4, and eventually we get our 40. Okay, so confirmed, the formula is indeed correct. Okay, so that's a bit of theory about that. Now let's talk about the geometric series. Okay, let's talk about the series now. We're done with the sequence. That's as far as you can get as formula is concerned. Now, for geometric series, when we are talking about the series, we really talking about the sum, okay, of the terms. So instead of the commas, now we're gonna put sum series is 10 plus 20 plus 40. If we continue with our example. Okay, so that's our series. Now there's a general formula for series as well, Sn. Remember, when we're talking about series, we're talking about sum. So Sn stands for the sum, and it's given by a r to the power n minus 1 divided by r minus 1. That's it. That's the formula. So if they ask us to solve the first 5 terms, the sum of the first 5 terms, all we do then is we already know that a is 10. Okay, r, we calculated r to be 2. Okay, n, okay, is in this case n, I'll just leave it as n for now. Okay, which is completing the r is 2 minus 1. So the sum of the fifth now, the sum of the first 5 terms. Okay, so instead of n, we will put 5 this time. Okay, so it's 10, 2 to the power 5 minus 1. Okay, 2 minus 1 is just 1. Okay, and then we can continue. We'll say 10 times 2 to the power 5, I think it's 32, if I'm not mistaken. 32. Okay, so it's 10 times 32, which is 320. So if you add the first 5 terms, you will get 320. Okay, so that's it. Let us continue. Okay, now it is possible to sum an infinite number of terms only in the geometric series, but this only happens under special conditions. Okay, let me just write this down. You can sum infinite or infinite number of terms. The sum of the infinite number of terms, okay, can be summed or determined for, this only happens with a geometric series, no any other kind of series. For a geometric series. Okay, this only happens if your R, okay, your ratio is between 1 and negative 1. Okay, R can never be 1. All right, so R has to be between a negative 1 and 1. So if the number, if your ratio is bigger than 1, then you can't sum it. You can't sum the infinite number of terms. But if it's less than 1, then you can. Okay, now we need to talk about a certain key terms you need to understand. Okay, for example, if your R, okay, say for example your R is 1.5, or is a half, or rather it's just around 1/2. We say that this series is converging. Okay, it converges. It converges. But if R is so it's between a half, you can see that a half is between a negative 1 and 1, so this series is converging. But if it's greater than, say for example it's 2, then we say the series is diverging. Okay, it diverges. There's an R there. Okay, and then one more thing I just want to add out of interest. If R is a negative number, meaning it's less than 0, okay, then we say the series oscillates. Okay, let me just explain one of them one by one, what converging means. So if the series is converging, it means that there is a defined there is a defined there's a defined solution, meaning if you add the infinite numbers, if you add them, they lead to a certain number. Okay, it's a defined number. It's the only number there is. Okay, so it gives you an actual number. But if it diverges, it means there's an undefined number, undefined solution rather. Undefined solution means if you add the infinite numbers, it won't give you an actual answer. There is no answer. It goes up to infinity. There's no answer really if you add the infinite numbers. So it's undefined. Okay. And if it is oscillating, that means it, for example, it moves from a positive number, or rather the sequence is positive to a negative number to a positive number again to a negative number. So it keeps it oscillates. Okay, so when we say something is oscillating, it's oscillating like this. Okay, it moves from a positive number to a negative to a positive to a negative. It's just oscillating that series. So you can have a converging one that's oscillating or a diverging one that's oscillating. The thing that makes it oscillate is if the ratio, the common ratio is negative. Okay. Now, if under these special conditions where it converges, meaning R is between negative 1 and 1. Okay, then the formula for the sum of the infinite numbers is a defined equation given by a divided by 1 minus r. Okay, so you can sum the numbers of the series of a converging series, but if it's diverging, then you can't use this formula. You have to use the other sum formula. Okay, you can use that one. So this formula here, this sum formula here, it works for both converging and diverging if you have a certain number. So say for example you are summing the first 5 terms. Can use this formula for any whether it's converging or diverging. But if the question asks you to solve the sum of the infinite numbers, it can only work with the series being in convergence, meaning it's converging. If it's diverging, then you cannot use this formula. Clear? I hope that's clear. Okay, let's move on. So let's say, for example, let's make an example of this, how this formula would work. Say, for example, you have a series, it's 40 plus 20 plus 10. We just switched it up. This time A is 40 because it's the first term, and then R is term 2 divided by term 1, which is going to do that only, which is given by 20 divided by 40. It's a half. So a half is between minus 1 and 1. Okay, it's between minus 1 and 1. So we can definitely use the formula on this one. We can sum the infinite numbers. So A from this formula is 40 divided by 1 minus r. Okay, so that gives us 40 divided by 1 minus our r is a half. So it's 40 divided by a half, which would give us 80. Okay, so let's answer this question that we first heard. Now, this is the sequence. Determine the nth term of the sequence if it's equal to that. So let's always write the formula down first. That's the first line of defense. So the right formula here, if you remember correctly, is I said I put r in brackets and then n minus 1. Okay, now what is A in this question? You said it, got it right. It's 30. And then R, we can solve R. Let's say term 2 divided by term 1, which is given by term 2 is 10. And term 1 is 30. So just to simplify further, it's a third, 1 over 3. Okay, now we can plug these numbers into the equation. So the equation, the full equation is Tn is equals to 8, which is 30, in brackets R, which is a third, okay, and then n minus 1. Now the question is telling us that the term is 10 over 7 to 9. So under Tn, that's what we will put, 10 over 7 to 9. Okay, and then the rest of the equation, because the question actually wants us to solve for n. Okay, so we'll just we'll divide both sides with 30. Okay, let's do that. And just bring in a calculator. Bring it down here. So I'm gonna have 10 divided by 7 to 9, and all of that I want it divided by 30. Okay, let me give this in fraction form. Okay, let me just increase my screen. There you go. Come on, calculator. Still not big enough. Let's increase you again. There we go. Sorry for wasting your time, but it had to be done. Anyway, we have 1 over 2187 is equals to, this time, 1 over 3 to the power n minus 1. Okay, thank you so much. Now, as a general rule, when you are trying to solve this kind of equation, when you have a fraction like this, 1 over 3 n minus 1, what I like to do is that I want to, have 1 over 3 represent this number. Okay, represent this number. So now I need to figure out the exponent that I will need to put there. You have to, it's either you know it by head or you can do a trial and error. Okay, you can do trial and error. So you can say, because anything to the power, 1 to the power of anything is still going to be 1. So don't mind about that. This is what you must mind about. So it should be 3 to the power 7. Okay, so 3 to the power 7 is the very same number. It's 2187. This 2187. Okay, so at least we know to the power 7 up there. Now, if you have the same basis, it means you have the same exponents, so we can equate the exponents. Okay, for a detailed explanation of how to solve exponents, that's another lesson. You can book a lesson with us, and we'll be glad to tutor you through it. So, and therefore, if you take this one to the other side, you add it, and then n is 8. Okay. Did we answer the question sufficiently? The nth term is 8. Okay. Now it says calculate this. Okay, 2.1.2. So here, okay, you can see that now we're dealing with a series. It's no longer a sequence. And the thing that makes it a series is because we are adding the numbers. So what you need to know about this type of series is whether it's diverging or converging. Now, since our R is a third, that means that it's our R is actually between 1 and -1. Okay, because R is a third. So R is a third, meaning therefore it's converging. Okay, since it's converging, we can sum the numbers. We can sum the infinite numbers. Okay, because this, these dots, they mean that you are continuing. It's an infinite number of numbers that you must sum, that you must calculate. Okay, so we add up all the numbers in that series that are infinite, and we have an equation for it. It's just a divided by 1 minus r, which is equals to our a. In this case, if we are to go back, our a is 30. Okay, so it's 30 divided by 1 minus r. Our r is a third. Okay, so we just need to put this in a calculator real quickly. Okay, let's put a fraction. Let's put 30 on top. Let's come down here. We have 1 minus a third. Okay, a mini fraction there, which has 1 on top and 3. That's equals to 45. That means that if you sum up the infinite numbers, it will give you 45. All right, so we're ready to answer this question as well. So let's get right into it. Themba is planning a bicycle trip from Cape Town to Pretoria. The total distance covered during the trip will be 1,500 kilometers. He plans to travel 100 kilometers on the first day. For every following day, he plans to cover 94% of the distance he covered the previous day. Okay, so let's see the questions. What distance will he cover on the third day? To answer this, we need to get the formula first. Okay, so to get the formula, we need A, and A, we can see A is 100 kilometers. We also need R. R, we have been given, it's 94%. Now, you know 94% is basically, that percent means you are dividing by 100. So it's 94 divided by 100. Okay, and our general formula is given by A, R in brackets, which I prefer, and minus 1 as an exponent. Okay, so we do have A, it's 100. R, we have it, it's 94 divided by 100. And then N minus 1. Now they want us to calculate the third day, meaning T3. So we'll have 100, open bracket, 94 divided by 100. N is 3 minus 1. Okay, so I'll just quickly put this in a calculator. 3 minus 1 is 2. So we have 100, open the bracket, put a fraction there, 94 divided by 100, okay, close that big bracket, to the power 2. Okay, let me just change it into a decimal. It's equals to 88.36. Okay, so what we are given units here, kilometers. Don't forget the units. You are allowed not to put units while you are working out the question, but at the end you must put the units. Okay, 3.2 says, on what day of the trip will Themba pass the halfway point? Okay, so the halfway point, let's start there. What is the halfway point? The halfway point is half of 1,500. So let's just start there. is 750. That's the halfway point. So that's the summation of the of the distances. If you add all the distances, they must equal 750 kilometers. So we are really dealing with the sum equation, meaning we are dealing with a series as opposed to a sequence now. So the sum equation, if you remember it, it's a r n minus 1 divided by r minus 1. Okay, now there is a, as you can see from the equation as well, one more thing I forgot to tell you is that r can never be equals to 1. It can be any number but 1, the ratio, because if it's 1, then this will be undefined. 1 minus 1 is 0, which it makes the whole thing undefined. Okay, but let's just carry on. Okay, so we have here that we've been told that we will want the halfway, which is 750 over, which is 750. A, we have A, it's 100 kilometers. Okay. We have R. Okay, I'm gonna do this. I don't wanna write R in a fraction, so I'm just gonna go ahead and divide it. So it's 94 divided by 100, and we get 0.94. Okay, so I'm just gonna put 0.94 to the power n minus 1. Okay, and divide the whole thing by 0.94 minus 1. Okay, now it's just a matter of working this thing out. So we're gonna cross multiply really. So I'm gonna take this and put it on top. So it's gonna be 750, 0.94 minus 1. And all of that will be divided by this 100. So that this side I'll be left with 0.94 minus 1. Okay. Now all I want to do is really just simplify it further. So I'm gonna cancel 1010 on each side so that I have 75. 0.94 minus 1 divided by 10 minus 1. It's not going to be minus. If I bring it to the other side, it becomes plus 1, so that I'm left with 0.94 to the power n. Let's put this whole thing in a calculator now. You can put 75, open the brackets, 0.94 minus 1. Close the brackets, come down, divide by 10. Okay, and then we add 1. We get 0.55. So 0.55 is equals to 0.94 to the power n. What I really want to solve is n. Okay, now we need to use logs. Okay, and by the rules of logs, if you want n, you will say log. The base of the exponent becomes the base of the log as well. And then there you just put the opposite number, which will be 0.55. Now, if you don't know the laws of log, book a session with us and we will quickly tutor you on that. Okay. So what are we putting there? We want log, okay, with a base of 0.94. And then there we have 0.55. Okay, so we get n is equals to 9.66. Now let's get the units. Okay, 3.2 on what day? So we're talking about days. You can never have 9.66 days. Okay, that's not possible. Days have to be in whole numbers. So that's really approximately 10 days, because 9.66, if you round it up, it becomes 10. So we get 10 days. Okay, let's go to 3.3. It says timber must cover a certain percentage of the previous day's distance to ensure that he will eventually reach Pretoria. Calculate all possible values of this percentage. Okay, so first of all, is this series converging? Because now we're talking about series. Okay, is it converging or diverging? Okay, that R will tell us. It's 1/3, right? And 1/3 is between -1 and 1. Okay, so it is converging. The series is converging, meaning we can use the sum into infinity equation. Remember, it was given by A over 1 minus R. Okay. Now, we know that the total distance is 1,500. But if he is to eventually reach Pretoria, that means the R that we have to solve must give us at least 1,500. It can give us 1,500 or more, which means the R must be bigger. Okay, it can be anything bigger than the one that we already have. Okay, so that's the best way I can explain it, that this is the least distance he can cover, meaning there must be more to it. So our A, we already have our A that it's 100. 1 minus R. R is the one that we need to solve. Okay, we need to know what R is, the minimum number of R that will ensure that he reaches Pretoria eventually. So we're just gonna cross multiply, which becomes 1/R is less than 100. That comes here. Divide by 1,500. Okay, so I'm gonna move things around. I'll move the R that side and then move this, so that I'll have 1 minus 100 over 1,500, still less than R. When R goes to the other side, it becomes positive, right? So let me just quickly put this in a calculator. Okay, so I have 1 minus 100 on top, and at the bottom 1,500. I have that it's 0.93. So we can therefore say that R must be greater than 0.93, or R must be, if I'm to convert this into a percentage, it must be greater than 93%. Okay, so if R is greater than 93%, it means that he will eventually reach Pretoria. But if it's less than 93%, then he won't reach it. Fortunately, he was covering 94%, as you can see from the question, which is greater than 93, which means he eventually reaches Pretoria. Okay, so it all has to do with eventually, meaning at least. Okay, well, that covers the tutorial of the day. I hope you understood everything, but in the event that you didn't and you want me to explain again to you or in another way, feel free to comment or visit our website and book a session with me. Okay, thank you very much.